Science A, Unit 6 Arrays, Lesson 2, Algorithms, Searching. At the conclusion of this, you should be able to understand how to use a for loop to search for a value in an array and examine an implementation of this algorithm. You should also be able to examine other algorithms that use the same for loop structure to traverse an array. Searching an array is doing exactly what it sounds like, but think about what information we would want to know. For example, in a list of names, we have an array of strings that we're going to call names, and in this array, we have the names Mila, Princess, Scrappy, Snowball, Thor, Scooby. If I wanted to search for Scrappy in my array, what information would I want returned? I wouldn't want the value I searched for returned because I already know I'm searching for Scratchy. I know what that is in the beginning. I could return a Boolean value that simply lets me know if the item was in the array or not. True, false, true it's in the array, false it's not. But a more useful piece of information would be to know what the index is, where the value is located. So, if a value is found in an array, then we would return the index where it was found. If the value isn't in the array, then a value that would not normally be returned can be returned instead. Now remember, we could have an array of any length of strings. So this is how the string method .indexOf works. When the value cannot be found, in the string, -1 is returned because it isn't a possible index. I can't index to -1. Now, here's a summary of the information about the method that we will be writing. The return type, returning an array index, and in Java it's going to be an int. The index is an int. The method name, this method will search for an array for a value, so we're going to call search linear. The first parameter that we're going to pass to it is the value that we're looking for, string S. The second parameter is the array through which we're going to be searching. And we're going to use a generic name like array, or not array, but R for array. So, and it's going to be an array of strings. So here I'm going to call it search linear. It's returning an int. I'm first passing it what I'm looking for, then I'm passing it the list or the array in which I'm looking for it. The return values. If the string to be found is in the array, then I'll return that index. So it'll be the value 0 up to array.length -1. On the other hand, if I don't find it in the array, then I'm going to return -1 because -1 is not a valid index into an array. Now, recall that the proper way to compare two string values for equality is the .equals method instead of the double equal operator. However, this will introduce possible complications. Recall as well that a string may have the special value null, in which case trying to use the .equals method will generate a null pointer exception. So it is important to first make sure that each string is not null before trying to compare them for equality using the .equals. So, this is a common algorithm for searching an array and is commonly called the linear search. Here's the pseudocode for the program. Get the value to find and the array as parameters. If the array is null, return -1. That means we don't even have a list, so it can't possibly be there. Otherwise, loop over each value in the array. If the array element is the same as the value to find, return the current array index. If the end of the loop is reached, then the value isn't in the array, so return -1. So again, here's our little cat looking through everything. Now, here's the code. And we're going to look at, on your screen now, you can see the linear search algorithm for an array of strings. Public static int, right? Let's see if I can get a better point. Int is our return type. Search linear is the name. I'm first passing it a string that I want to find, and then I'm passing it an array of strings where I want you to look for string S. Now, if the array that's passed in is null, immediately return -1. I've got an empty list or an empty array, so it can't possibly be there. If the return doesn't happen, then it's going to drop down, it's going to go into this loop. For int I starts at 0 and goes up to the array length -1, because remember, it won't be, once it equals the array length, it'll jump out of the loop, and it's going to go up by 1. So it's going to check every single element. If the array value at that element equals the string, then we're just going to return I. Boop, goes back. Otherwise, we're going to check the next element. So it loops around and around and around and around. If I drop out of this loop, if I get to the point where I've reached the end of my array and I drop out of the loop and I have not returned, then string S must not be in the array. So again, I will return -1. Now, what if we want to use the linear search algorithm for an array of ints instead of strings? What is it going to look like? Well, notice here that public static int search linear, that's exactly the same. What changes? The type of value I'm looking for and the type of value stored in my array. Otherwise, it's very similar. Then what happens? Well, notice this part looks exactly the same. I'm just checking to see if it's an empty array. And then here, this part, well, that looks almost the same. What's different? The equals. Okay, remember that if I'm comparing ints, I use a double equals because those are primitive types. A string is an object, so therefore it needs to use the dot equals method. So here I just use the double equals in place of the equals method. But again, I'm just going to return I or return -1, and the loop structure setup is the same. So there's not a lot of difference here. Very, very similar. Now, if I'm searching an array for a minimum or a maximum value instead of a specific value, usually we do this when we are working with int and double, but the process would be able to be applied to strings. We just would have to first convert, convert them first. Let's examine a new data set for this example in an array called numbers. So int, I've got an array of numbers 12, 15, 11, 9, 10. A quick glance at the table reveals that the smallest value is 9. Visually, we can all see that. And it's stored at index 3. Remember, we have index 0, index 1, index 2, and I'm doing this with the mouse, index 3. So, stored at index 3. However, if this array contained a list of 1,000,000 numbers, it would take much more than a glance to establish what the smallest value was in the list. In such a case, an algorithm would make more sense. So our algorithm, our return type is going to be the array index, which is type int. Then the method name is going to indicate what we're doing. Index min. I want the index of the minimum value. And then you got to pass it the array. You only need one parameter because I only need the array. I don't know what the minimum is yet. And then the index of the element with the lowest value will be between 0 and array.length -1. Now you might also want to say that it's the first time or the last time. Which one is it? Linear search for minimum value. Public static int, type that we're returning, and then we're getting an array of integers. And this one, sorry, for maximum value, ignore the green right now. We go through here, we start out at 0, and we set the minimum value in the array to the first element. Then what we're going to do is we're going to go through the array, starting with 1 and going to the end, and we're going to check. If minimum is more than the current element, we're going to swap it. Minimum is just going to get the array sub I, and index is going to be I. and we're going to come back up and loop again. If, on the other hand, the minimum is less than or equal to the value, the element in a race of I, then I skip over this if and I just go to the next element. And finally, I return index. So if the very first item is the smallest, I'm going to return 0. Otherwise, I'll return wherever it came to. Now, for our maximum, well, for maximum value, instead, I would call it max, not min, so it's not confusing. I would also call the whole array, index max instead of index min. And then here, I would turn it around. If maximum was less than the current element, then max would get a race of I and index would get I. So notice, with the code for one, you pretty much have the code for both with minor alterations. And that concludes lesson 2, searching for a specific value, searching for a maximum or a minimum value in arrays.